All right, so section 4.3. So in that notes packet, it starts out on the top of it saying 4.3, writing equations of parallel and perpendicular lines. And it says core concept, parallel lines and slopes. And it says two lines in the same plane that never intersect are parallel. Okay? So when you have two lines that never intersect, meaning that they never touch each other or anything like that, and they're in the same plane, they are known as parallel. Can anybody think of an example in the world that demonstrates parallel lines? Just so you know, there are many in this room, but does anybody know of any that would demonstrate parallel lines?
Parking.
What do you mean parking?
Parallel park.
When you parallel park? Okay, all right. In parking lots, the yellow lines, right? Those are supposed to be parallel, correct? Anything else?
No.
Nothing else that you guys can think of that would be giving you parallel?
The Adidas logo?
Huh?
The Adidas logo?
The Adidas logo? When you look at the three stripes, they are parallel, exactly. Here's one that I always use because they never come any closer. Train tracks. Think about train tracks. They're not going to go out wide and then come back in, are they?
Mm-hmm.
Or they're not going to do this because otherwise the train would wreck. That only happens in the cartoons. Like they should be the same distance apart the whole way. So that's my example of parallel. Then it says two distinct non-vertical lines are parallel if and only if they have the same slope. So the big thing with parallel is that they have to have the same slope. So that means their slopes are going to be identical. So if I find a slope and if I say parallel to it, they have to be the same slope, same numbers. Okay? And it also says all vertical lines are parallel. So when you think about vertical lines go north and south, right? Those will always be parallel. So on example 1, it says identify which of the lines are parallel. So we have to find the slope of those ones. And for this particular thing, part A, and I'm not going to take a picture of it today. I'm just going to look at the ordered pairs that they give you. Line A has the ordered pair of -4, 3, and 1, 2. Does everybody see that on your example? Now, what I'm going to do is I'm going to find the slope. So we've been dealing with this now for a couple weeks, right? Finding the slope using this formula. What number is in the y2 position? 2. Good. Minus, what's in the y1 position? 3. Awesome. Divided by, what's in the x2 position?
1.
Minus. And what happens when you have two negatives in the bottom like that in a row? Becomes a positive. Good. Now, let's look at the top. What's 2 minus a 3? -1. Good. And what's 1 plus 4? 5. Awesome. So there's my slope for line A. Line B has the ordered pairs of -3, 0, and 1, 1, or 1, -1, sorry. So I'm going to do the same thing. What's the second y in this problem? -1 minus, what's the first y? 0 over, what's the second x? Minus, okay, that bottom turns into a positive. Good. On the top, what's a -1 minus 0? -1, good. And on the bottom, what's 1 plus 3? 4. Now, so far I have the slope for lines A and lines B. And in order for them to be parallel, they have to be identical. -1 over 5, and this was -1 over 4. They're really close, but the bottom number is different, isn't it? So are those parallel so far? No. Then line C has the ordered pair of -3, -4, and 2, -5. So which one is y2? -5, good. -5 minus. And what did two negatives do? On the bottom, what's x2?
2.
Minus.
-3.
Nice job. And what happens there?
-5.
Good job. On the top, a -5 plus 4 is -1. And on the bottom, 2 plus 3 is 5. Now, when you're looking at this problem, which of those lines are now parallel? Which ones are the same?
A and C.
A and C. Right. You need to identify which ones are the same, and you've identified that A and C match. Okay, that's how you do an example problem like that. You find the slopes of all three of them, and then you figure out which ones match. What if it would have been where all of them would have matched? That is an option. You could have had all A, B, and C match. They could have all been the same. Okay, so you won't know. So my point is with this one, you guys, don't just assume once you find, like, let's say A and B match, and you go, oh, that's it, A and B. It could be where A, B, and C all match. So you got to do the slope for all three. And then identify which 2 or 3 are the same. How do you guys feel about that so far? Not too bad? All right. Number 2, or example number 2, has write an equation that passes through the ordered pair of 5, -4, and is parallel to, and just so you guys know, me being a math teacher, I don't like to write, so I use symbols for stuff. 2 lines like that right next to each other is not an 11. It's parallel. That is the symbol for the word parallel. Okay? Looks like 2 L's. If you think of the word parallel has 2 L's in it, in the middle. Now, what's going to happen with this problem? It says, write an equation of a line that is parallel to your given line. So with the given line, here's what you need to do. You need to steal something from it. You need to take something away from it. That's what you're going to do. What I need you to tell me, for the line that they give us, the y equals 2x plus 3, what is the slope of that line? What number is in the slope position? Just the 2. The x is a bonus part, but just the 2. Okay? So when we're looking for the slope, we want the number that's in front of the x. So I know that the slope of the parallel is equal to 2. So here's me using symbols. M stands for slope. 2 little lines like that means parallel. So what I have to do is I have to take the slope from the one that they give us, and now I'm going to use this ordered pair to come up with the equation. And if you remember from what we've been doing, we have a point and we have a slope. So y minus, what's the y coordinate of the point they give us? Equals, what's the slope that we're going to use? 2. X minus, and what's the x coordinate of the point they give us? 5. Nice. So now, to clean this up a little bit, 2 negatives in front of that 4. So y minus a -4, what happens with the 2 negatives? So y plus 4 equals. Now what I'm going to want you to do is I want you to distribute this out. What's 2 times x? And what's 2 times -5? -10. And now the form that we want to get it into is we wanted to get it into slope-intercept form. It never says that, but that's what it wants you to get it into. So in order to do that, I got a +4 that's on the wrong side. How do I move a +4? Yeah, you subtract it. Good job. So what's negative 10 minus 4? Negative 14. Nice job. So again, what I did was I pulled the slope out of the one that was given to us. So I took the slope from here and then used a point and a slope in order to create my new line. So if I were to graph both of those, what would happen is that I have two lines that are going like this. Like they're side by side. They're not going to touch each other though. They're not going to intersect. Okay, that's number 2. And now on the bottom of that page, they have a check for understanding, and they give you line A passes through negative 5, 3, and negative 6, negative 1. That's line A. Line B is through 3, negative 2, and 2, negative 7. Ooh, forgot the negative. The question's asking you, are they parallel? So the question's yes or no. So what do you think you have to do for this problem? How would you know if two lines are parallel? If they don't touch. But what are we looking at specifically to know if they're parallel or not? Uh-huh. The points? I'll also give you another hint. It starts with the letter S and rhymes with lope. Slope. We got to find the slope. So on the first one, line A, what's y2? Negative 1. Minus, what's y1? 3. Good. Over. What's x2? Negative 6 minus a negative 5. And as you guys have said many, many times already today even, 2 negatives in a row make it a positive. What's negative 1 minus 3? Careful. If I'm standing here and I take a giant step backwards, that's minus 1. Then if I go back 3 more, 1, 2, 3, how many am I back total?
Negative 5.
Try again.
Negative 4.
Negative 4. Because Quentin, I went back 1, and then I went back 3 more.
Oh, you said negative 1. I thought it was 2.
No. On the bottom, what's negative 6 plus 5?
Negative 1.
Negative 1. What's negative 4 divided by negative 1? What's a negative? A negative divided by a negative is a positive 4. Good. Now let's check the slope for the bottom for line B. What number is in the y2 slot?
Negative 7.
Negative 7 minus
Negative
2 negatives make it a.
2. Positive
On the bottom, what's x2?
2.
Minus.
3.
So on the top, what's negative 7 plus 2?
Negative 5.
Negative 5. And on the bottom, what's 2 minus 3?
Negative 1.
And 2 negatives make it a.
Positive.
Are they the same numbers, yes or no?
No.
No. If they were parallel, they should have been the same numbers. Since they are not parallel. Does that make sense?
Sir.
So you got to find the slope, and then you look at the numbers. If they're exactly the same, you'd write a yes. If they're not the same, you write a no. Then, the other one that's on the check for understanding has negative 4, 2, and is parallel to y equals 1/4 x plus 1. So when you're doing this problem, remember what we want to take from the line that they gave us. What do we need to take out of the line that they give us?
Negative x.
I need to take out the 1/4. I need to borrow that slope for a second. So my slope is equal to 1/4. So now setting it up using the formula, y minus, what's the y coordinate of the point they give us? 2 equals, what's the slope? 1/4. X minus, what's the x coordinate of the point they give you?
Negative 4.
2 negatives make it a,
Positive.
good. Now, once I do that, I'm going to distribute. What's 1/4 times x?
1/4
Then the last one, what's 1/4 times 4? Someone other than Alyssa. Yep, what's 1/4 times 4? Not negative. Positive 1. Good job. Nice work. Then in order to get y by itself, how would I get rid of a subtract 2? Add 2. And what's 1 plus 2? 3. So my answer to a line that's parallel to it is 1/4 x plus 3. So if you look at what we just did, this isn't anything new from what we did from 4.1 and 4.2. Okay, this is still the same, coming up with the equation of it. It's just making sure we take the slope from that one. Okay? Then when we turn the page, it goes on to perpendicular lines. 2 lines in the same plane that intersect to form right angles are, and the word you're looking for is perpendicular. It says non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. So let's talk about what it means to be a negative reciprocal. Negative reciprocal means that it's going to have the opposite sign. So if it was positive, it's going to be negative and vice versa. And reciprocal means it's flipped over. So the reciprocal of 2, for instance, is 1/2. The reciprocal of 3/4 is 4/3. Okay, now, negative reciprocals, that's the official name for it. Another thing that I do to help remind myself what it is, I've used the words opposite reciprocal before, just so that I get the sign in there. Or an even easier way of saying it is flip it and reverse it. So flip it and reverse it, meaning the sign. Okay? So when you're trying to find perpendicular, one of the things that you can do for the slope is you can flip it and reverse it. That's kind of an easy way of saying that. Then it also goes on to say vertical lines are perpendicular to horizontal lines. Then, for example 3, it says line A is y equals 4x plus 2. Line B is x plus 4y's guy equals 3. And line C is negative 8y's guy minus 2x equals 16. In order to know what slope they have, they all need to be in slope-intercept form. Slope-intercept form is the y equals mx plus b. Are all these in y equals mx plus b format?
No.
No. Which one is?
Line A.
Line A is in that format. So, which one is in the m position then? Which number?
4.
4. So for line A, the slope is 4. So now we need to get it into that format. We need to get y by itself. So for line B, the first thing you'd move is you'd move the x. How do you move a plus x? Good. So if I subtract x to both sides, I end up with 4y equals negative x plus 3. And how do I get rid of a times by 4? Divide by 4. And when I do that, I do it to each piece. So I get y equals. Now, if you notice, there's no number in front of the x. If there's no number in front of the x, it's understood to be a 1. So this is really me saying negative 1 divided by 4x. So negative 1/4 x plus 3/4. So what's the slope of line B? What number's in the M spot?
Negative 1/4.
Is line C in that same format, y equals mx plus b? No. First thing I need to do is I need to get rid of the x. How do I get rid of a minus 2x? How do I move it? Add it. Good. If I add 2x to both sides, I get minus 8y equals 2x plus 16. Now, with that, here's what doesn't happen. And I'm saying this because I had someone I was working with on Friday. This is what they were doing. They were taking these two and combining it to make it 18x. 2x plus 16 does not combine together. If you have an x and you have a whole number like that, they don't work together to make 18x. This is like apples and bananas. Yes, they go in your grocery cart, but they're not charged the same. So leave them separate. Okay? How do I get rid of the negative 8 there?
Divide.
Good. And when I divide each piece by negative 8, I get y equals. When you have a 2 divided by negative 8, that reduces by 2. What's 2 divided by 2?
1.
1. What's 8 divided by 2? Good. And notice what I did with the negative. I just put it in the front. 1 negative, just put it in the front. And what's 16 divided by negative 8? Negative 2. So what's the slope of this line? Of line C? Negative 1/4. Now, the question is, which lines are perpendicular? So, when you look at these two slopes here, B and C, they are the same. The same slopes mean that they would be what?
Parallel.
They'd be parallel. What is the flip it and reverse it of negative 1/4? So flip it over and then make it the opposite, meaning reverse the sign. So if the sign was negative, it should be a positive, right?
Mm-hmm.
Is there a positive 4 on the board?
Yes.
Where?
Line A.
Yeah. Line A is perpendicular to both B and C. Because this flipped and reversed is negative 1/4. And vice versa. So line A is perpendicular to both B and C. So on those problems, if you don't check all of it, you're going to get something wrong. Because if you notice, line A is perpendicular to both these lines, not just one of them. On those problems on big ideas, and I know that for a fact because I was helping somebody in this class on this assignment, that's what was happening is they only found one and they thought they were done. Okay? You got to check it all. All right, example number 4. It says write an equation that goes through negative 3, 1 and is perpendicular to y equals 1/2 x plus 3. So again, you notice how, remember how I said that parallel had 2 sticks,
Yes.
right? Perpendicular is an upside down capital T. This is the symbol that we use to stand for perpendicular. Perpendicular means a couple different things. It means two lines that intersect and form a 90-degree corner. Hottest place in a room. Okay? Do you have 90-degree corners in this room?
No.
No? I would really actually hope that they are. Because if not, the building's gonna fall down. Right? Look, every corner in the room should be 90 degrees.
Oh,
That's why it's always the hottest place, right? Because it's 90 degrees in the corner? No? Nevada. Sure. So, first thing I want you to do is, what's the slope of the line that they give you? So what's the slope of this line that's over here that they give us? 1/2. Good. So you've identified that the slope is 1/2. Now, to get the slope of the perpendicular, which is an upside down capital T, I need to flip it and reverse it. So what is 1/2 flipped and reversed?
just 2. Or 2 and 1.
Close. You flipped it good. Reverse the sign. My slope would be -2. Now, Antoine, you also said 2/1. I would take that if you put 2/1 as well. Okay? Just, you got to make it -2/1. But, just so you know, you could have it as a 1 underneath there, or you could get rid of the 1 at that point. Now, writing my equation, y minus, what's the y coordinate?
1,
1 equals, what's the slope?
-2,
Times x minus, what's the x coordinate?
3,
2 negatives make it a,
positive,
good job. Distribute, what's -2 times x? Good job, Zach. What's -2 times 3? And then how do I get rid of a subtract 1? Add 1. Good job, Zach. Y equals, what's my final? -2x -5. So the perpendicular line to 1/2 x plus 3 that goes through the point -3, 1 is at y equals -2x minus 5. Okay, so again, what you have to do is take the slope that they give you, you got to flip it and reverse it, and then plug it into the format or formula. Okay? What do you guys think? You want to do another one? No? Okay. On the bottom of that, the check for understandings, there's just like example, the first one's just like example 3, and the second one's just like example 4. Then on the back page, oh, we're done. It says the position of the helicopter search and rescue crew is shown on the graph. The shortest flight path to the shoreline is the one that is perpendicular to the shoreline. Write an equation that represents this path. So, first of all, we need to, do you see where the helicopter is at? What order pair is that helicopter at?
14 and 4.
So 14 and 4 is the order pair that we're using. Now, we need to find the perpendicular line, so we need the slope. Oh boy. Looks like we need to go and find another dot where it hits. Do you guys see that it looks like there's a dot at 12:1? Does it look like it crosses right at 12:1?
Oh, yeah, she is.
You see it? Okay. So let's find the slope first. What's the slope? What's the y2 coordinate?
1,
Minus
4,
over What's x2? Minus 14. Nice job. What's 1 minus 4?
Negative 3.
Over. What's 12 minus 14?
Negative 2.
2 negatives make it a? So that's a positive 3 halves. Now, here's where it gets a little bit tricky because it's saying that we want the perpendicular to that shoreline, and we're basically using the line that it gives us, isn't it? Not the shoreline itself. We could have found the slope of the shoreline if we wanted to, then flipped it and reversed it, and then done the other one. But we use the line, we use the slope right from the aircraft. So we should be good. So now, y minus, don't use the 12 one. I would use the 14 and the 4. You know why I'm going to use the 14 and the 4? Yeah, it's on the actual thing. It actually shows it, doesn't it? So y minus what?
4.
Equals 3 halves x minus 14. We're going to use the 14. Good. Distribute. What's 3 halves times x? And here's the tricky one. What's 3 halves times negative 14? I'll give you a hint. It's a negative number.
Negative 21.
Negative 21. Good. Miss Liz, how'd you get that?
I put in 3 half times negative 14.
In your calculator?
Yes.
All right, awesome. So Elizabeth used her, or not Elizabeth, Alyssa, good Lord. Alyssa used her calculator to come up with that answer. Great. Good job. Okay. What I did to get negative 21 was I took 14 divided by 2, which is 7, and then 7 times 3. So I did it in my head without doing the whole thing without a calculator. But you use a calculator, it's fine. Now, how do I get y by itself? How do I get rid of the 4?
4.
Add 4. Good job. What's negative 21 plus 4? What's negative 21 plus 4? 17. Negative 17. So the flight line for that helicopter to get to the shore as quick as possible is 3 halves x minus 17. Okay? And just so you guys know, like they use this stuff a lot. Pilots do, and air traffic controllers, as well as some other things that are in math, like trig, in order to land planes and get the proper angle so that they don't come in too steep or too low. They use this stuff all the time. And I know that firsthand because my sister is an air traffic controller in Atlanta. That's what she does for her job. Okay? What do you guys think? It's basically coming up with lines, isn't it? And then you also have some parts in there where it's going to say parallel and perpendicular. So parallel, they're the same slope. Perpendicular, if it's flip it and reverse it. Okay? How do you guys feel? Feel pretty confident on it? Or at least try it. We'll see what happens. All right, so I'm basically giving you no time to work yet. So tomorrow I'll give you the hour to work on your 4-3. Okay, and then we're done with chapter 4. So then that means that what we're going to do is on Wednesday I'll give you guys kind of a review assignment that'll cover all of it. And then on Thursday we'll go through it all. And then on Friday I'm going to give you guys a little quiz over chapter 4. Just so everybody knows. Okay?
What time is class?